In our last video, we were simplifying radicals that were square roots, so the index was 2. So now we're going to be simplifying radicals part 2. What we're going to be dealing with today is with my radicals, my number out front here, remember we called this an index. The numbers we're going to deal with today are 3 and 4. So really what we're looking at are cube roots and fourth roots. The cool thing is the process is still the same with our square roots, but instead of looking for groups of 2 or repeats, we're going to be looking for groups of 3 or groups of 4. So we're just going to dive in and look at some examples. So my first example that I'm going to do is I'm going to do 6 cube root of 16. So with this cube root, that tells me I'm looking for any factor that repeats 3 times. So 16, that's going to give me 8 and 2, and then I'm going to cube root those 2 factors. So again, that 16's gone. 8 becomes 4 and 2, and I'm going to cube root those factors. 4 becomes 2 and 2. So what we're looking at right now are the prime factors of 16. 2, 2, 2, and 2. That's a lot of 2's. All right, so right now what I'm looking at is 6 cube root 2, cube root 2, cube root 2, and cube root 2. Again, we're looking for groups of 3, which we have right here. What happens here is essentially this becomes 6 cube root of 8 times the cube root of 2. The cube root of 8, what times itself 3 times is 8? Well, that's 2. So this becomes 2. 6 times 2 times the cube root. So 12 cube root 2. But we kind of addressed this idea a little bit when we were doing our square roots. Because we have this repeat of 3, that's telling me the cube root of 2 cubed. The cube and the cube root are inverse functions. They're going to cancel out, leaving me with 2. So that's what happens here. These 3 get multiplied together, and it leaves me with 2. 2 times 6 is 12, and then we have that last one all to itself. Same process, different numbers. So let's take a look at another one. So this one is 4 cube root 54. So my factors of 54, I'm going to do 9 and 6, and I cube root both. 9 is going to give me 3 and 3. Again, cube root both. 6 is going to give me 2 and 3. So I'm left with 4 times the cube root of 3, cube root of 3, cube root of 3, and the cube root of 2. Here's my group, 1, 2, 3. So this becomes a 3. 3 times 4 is 12, and then I have my cube root of 2 left over. Wow! I got the same answer there. That just tripped me out for a second. Those simplified to the exact same thing. That's trippy. Cool stuff. Gotta love math. All right. So now let's take a look at our fourth roots. So my example here, I'm going to do 7 times the fourth root of 32. 32, be prepared. It's going to come with a lot of 2's. So let's take a look. Factors of 32, let's do 4 times 8, and I fourth root. 4 becomes 2 and 2, and I fourth root. I'm going to cancel stuff out because this one's going to get long. 8 is 4 and 2, and then 4 becomes 2 and 2. All right. So I'm looking for a group of 4. Here's 1, 2, 3, 4 2's. So I'm going to go ahead and cancel those 4 2's and call it 2 times 7. And I'm left with 1 4 root 2. So there's 14 4 root 2. Cool. Okay, I think we got time for one more, so let's go ahead and take a look. This one's going to look pretty crazy, but it's not too bad. 5 times the 4th root of 162. 162 is a little bit bigger of a number, but trust me, we can do this. Because it ends in a 2, I know it's even, so I'm going to start by a factor of 2. So I know it's divisible by 2. 2 goes into 16 8 times, and it goes into 2 once. So I get 2 times 81. All right, there goes my 162. 81 is 9 times 9. And 9s, they're both going to go to 3 and 3. All right. So there goes my 9s. So here's my group of 4. They're nice lined up together. 1, 2, 3, 4. So these 4 3's, or my 4th root 3's, become 3. 3 times 5 is 15. And I'm left with the 4th root of 2. Wow. All of my roots were left over with 2's. That's not always going to happen, so don't think you have to have a root 2. That's just the way my factors came together. Go forth, practice, good luck.